All right, let's dive into one of mathematics' greatest detective stories. It's a mystery that's been unfolding for centuries, and it's all about the hunt for a very special and incredibly rare kind of giant prime number. Take a look at these numbers. You've got 3, 7, 31, 127, even 2047. They all seem to share a secret, right? They're all born from the same simple rule. But here's the catch, the big twist that makes this so fascinating. Some of them are prime numbers, and some, well, they're imposters. And that is the mystery that has kept mathematicians hooked for ages. So, every good investigation starts with the fundamentals. Before we can start finding primes, we need to know exactly what we're looking for. Let's decode what these numbers actually are.
Okay, at the very heart of this whole thing is a surprisingly simple formula. It's written as m sub p, and it just means 2 to the power of p minus 1. That's it. You take a power of 2, you subtract 1. And when that result happens to be a prime number, we give it a special name, a Mersenne prime.
And look how beautifully this works for the first few. M sub 2 gives us 3, M sub 3 gives us 7, M sub 5 gets us 31. They're all prime. It almost feels like we've stumbled upon some kind of magical prime number generating machine, doesn't it? And you can see how quickly these numbers start getting bigger and bigger. That early pattern leads us to our first huge breakthrough in this case. This is a really crucial clue that helps us narrow down our list of suspects. This is our first big rule. It turns out, for one of these Mersenne numbers to even have a shot at being prime, the exponent, that little p up there, has to be a prime number itself. If you try plugging in a composite number like 4 or 6, forget it. The result will always be composite. It's a dead end, which is actually great news for us because it saves us a ton of work.
But here's where the mystery really gets interesting. A prime exponent is necessary. You have to have it, but it is not sufficient. In other words, just because you use a prime number for p doesn't automatically mean you've hit the jackpot. And that one little detail is what turns this from a simple formula into a grand, complicated, and amazing hunt.
And this leads us directly to the first major plot twist in our story. This is the moment where a beautiful, simple-looking pattern gets a whole lot more complicated. I mean, it's the obvious question, right? After seeing those first few examples, you'd think, hey, we've cracked it. Just plug in a prime and you get a prime. So let's ask it plainly. Does a prime exponent always give you a Mersenne prime? And the answer is a resounding no. Meet our first imposter, m sub 11. The exponent, 11, is definitely prime, so everything looks good on the surface. But when you look closer, the number 2047, it's not prime at all. It actually breaks down into 23 times 89. This is the first crack in our perfect theory, and it's such a great lesson in math. You never trust a pattern until you've done everything you can to try and break it.
And if M11 was a surprise, M67 was a total bombshell. Again, we've got a prime exponent, 67. But the result isn't just composite, it's gigantic, breaking down into 2 absolutely massive factors. And this is the point in our detective story where we have to put down the pen and paper. To hunt for giants like these, we're going to need some serious firepower. Which brings us right into the modern era of this investigation, and the incredible worldwide team of detectives who have taken up this ancient search. You know, this search didn't just start last week, it literally stretches back through millennia. The first clues were uncovered by Euclid way back in ancient Greece. Then, in the 1600s, a French monk named Mesmerizing gave this mystery its name. Centuries later, an incredibly powerful tool called the Lucas-Lemur test was developed. And today, the hunt is led by a global project called GIMPS.
GIMPS stands for the Great Internet Mersenne Prime Search, and the idea behind it is just brilliant. It's a distributed computing project. Thousands of volunteers, people just like you and me, donate their computer's spare processing power to join the search. It's amazing proof that modern discovery isn't always about a lone genius. Sometimes it's about global collaboration and a shared passion for finding something new. So, how can a regular home computer possibly check a number that has millions of digits? Well, they have a secret weapon, the Lucas-Lemur test. It's a super efficient, custom-built algorithm designed for one job and one job only, to tell us if a Mersenne number is prime. It's the perfect example of needing a very special tool to solve a very special problem.
So what has this global team of detectives actually found? Well, the largest prime number that we currently know of has this many digits, over 41 million. Just let that sink in. Not the number 41 million. 41 million digits just to write the number down. It's mind-boggling.
And here it is, the reigning champion, the 52nd known Mersenne prime, which was found by the GIMPS project back in October 2024. Its official name is 2 to the power of 136, 2798, 41 minus 1. A true mathematical giant, found not by one person, but by a global community.
But this story isn't just about finding bigger and bigger primes for the sake of it. There's a beautiful, almost magical connection that's been hiding in these numbers all along.
This is one of the most elegant connections in all of mathematics. Way back in ancient Greece, Euclid proved that every single time we find a Mersenne prime, we also get a bonus prize, something called a perfect number. That's a number where all of its divisors add up perfectly to the number itself. So, for example, the Mersenne prime 3 leads us directly to the perfect number 6. It's just a stunningly beautiful link between two ideas that seem totally unrelated.
So if there's one big clue to take away from this whole investigation, it's this. Being good at math isn't just about spotting patterns. It's about having the curiosity and the guts to really test those patterns, to push them and see where they break. Because that's almost always where the most interesting discoveries are hiding.
The search for Mersenne primes really is this timeless story of human curiosity. And it leaves us with this one last, really cool question to think about. What other incredible secrets are still buried deep in the world of numbers, just waiting for the next generation of explorers to come and find them?